Hi, this is RShinohara from CSC578, the online section, going over the code from homework number 1. And first of all, we'll quickly go over evaluate, where we now return the mean squared error, cross entropy, log likelihood, the number of correct predictions, and accuracy for each epoch. And the functions for each error functions are right here, right here, right here, and then accuracy is right here. And then the next modification that we made was the stochastic gradient descent function right here. And now it returns the performance from each epoch for the training and testing. And we started off with an empty list as so. And then the empty lists are updated for each loop right here, and if the testing set is included in the parameters, the testing list would be updated right here. And also the output from the SGD is also going to be modified so that it's printing out all the error statistics for each epoch. And also we have added a stopping condition for when the training set reaches 100% accuracy. And then we've updated the backprop function as well, so that we initially create a numpy array of all zeros of the same size as the network. And then that is updated in this for loop, and specifically right here. And for now, we're going to print each activation values right here. So let's move on to the application on Python Notebook. And let's quickly run this. And in part 1, we are going to see if the evaluate function, the stochastic gradient descent function, and the activations in the backprop updates are working correctly. And as you can see, it is working correctly because it matches the output that Professor Tamuro has showed us. This is the activations, and then this is the printout of the error statistics for each epoch. And this is also the return values from the SGD function. Now, moving on to the part 2, which tests if the SGD return values are correct and the early stopping conditions have been met. And before that, let me quickly comment out that so it doesn't clutter the page. And restart the kernel. Then let's run this part of the code and this part. And as you can see, it all seems well. And according to Professor Tamuro, if the stopping condition has been implemented correctly, the XOR dataset should end around the epoch of 18, which, well, it's not exactly 18, but it's close enough. And it looks like the array is printing correctly. And now, finally, let's move on to the applications for the iris dataset. And this is the first dataset, first network that I made. And it has it so that it runs to 50 epochs, and it is looking terrible. Look at all those 33% accuracies. Completely and utterly terrible. And then I modified a bit more right here. As you can see, the parameters of SGDs are slightly different from the ones from the previous one, as so. Not too different, but ends up that this is as good as it gets, which isn't convincing in this particular run. And then this is the complex network, so that I can hopefully get a good overfitting. And this isn't too spectacular as well. But at least everything seems to be running fine.